My talk of today is about how to exploit programmable hardware for analyzing the neural network's reliability. That is why one of my research topic. I chose to start this talk talking about autonomous vehicles because I think that most of you know what is an autonomous vehicle, and most of you probably remind Perseverance that during last year landed on Mars. Formerly, autonomous vehicles are vehicles capable of sensing the environment and moving safely with little or no human input. So the sensing of the environment is performed by cameras and radar and so on, so by sensors basically. And but for moving safely in the space, we need to understand what is sensed by the sensor. So for this task, usually we rely on neural networks. And so the idea is to use neural networks for perform three main tasks that are detection, classification, and sometimes also for taking the decisions. So what happens is that, for example, the camera takes an image, okay, so or a video that is a sequence of pictures. And I can detect where the objects are, what they are, and also what to do, because obviously I need to stop if I'm approaching a human being and so on. However, nowadays we are not in a world that is full of self-driving vehicles. So why we are not there yet, and what are the challenges that are preventing this technology to become popular? So the first problem is about, we can say, performance, because we need to perform a lot of operations for perform neural network task, and we need also to perform them at real time. So this means that I need to have my output in a short time, and I'm also working on embedded hardware usually, because I am on a car. So basically, I'm telling you that I need to do a lot of operation in a short time and on limited resources. However, more or less, we are almost close to solve this problem. We have a lot of devices dedicated to this kind of computation. They use a structure that is an integrated circuit, usually integrating together an accelerator and the CPU. Today I will tell you about programmable hardware. That is the one that I use more and I study, and it is also used for this kind of application. So programmable hardware devices consist of a matrix of configurable elements that we call tiles. And these tiles can be of a various type, like routing tile or logic tile, and I can configure these elements for implementing different functions. So basically, I generate the description of a circuit using the CAD tools, and I can implement this circuit in a pre-printed circuit in a way similar to a draw or to a puzzle. So for example, you can see that these tiles are configured together for build a circuit. If I change the content of this configuration memory, I can basically change the circuit using the same device. Sorry. So the idea is to use this programmable hardware for implement custom neural network processing unit, and this is what usually is done when we use programmable hardware for implement neural network accelerator for autonomous vehicles. But there is another problem that is related to the criticality of the system. So basically, autonomous vehicles are critical systems, so human lives depends on them. And so I need to respect some standards of functional safety. Functional safety is the ability of a system of operating correctly in response to its inputs or failure. I work mainly in this part of the definition on the failures. It means that my system needs to work correctly with all the inputs, but it also needs to work correctly if there is a fault in the system. Okay? So the faults are abnormal conditions that can cause an element to fail. They can be caused by several sources like ionizing radiation, aging that can lead to deterioration, or interference, malicious attack. So there are many sources that can produce a failure in a system. So we need to evaluate the reliability of the systems against this kind of faults. There are two main techniques to do so. One of it is basically a high-level software, high-level analysis of the software that run on an hardware. It is good for preliminary investigation. It is very fast and very easy in the sense that I don't need too much equipment to do it. And there is then the radiation test that is basically use the real hardware in a radiation facility where I use a radiation ray for create errors inside the device. The problem is that this analysis is also it is also very hard to execute because it needs a facility that provides you the environment for the radiation testing, and it also requires money and competencies. So what I did is to propose a system, a framework for exploit the hardware programmability for forcing faults in the circuits. So the idea is to act on the configuration memory of the device for forcing specific faults in an hardware platform for neural networks, and also choose which faults to inject in the system. So basically, I have a programmable hardware where I implement a neural network engine, and this engine works without faults, classifying the inputs. Then I can access with the platform to the configuration memory and change the configuration memory for insert a specific fault on purpose, so that I emulate the effect of a fault in the system, in the hardware basically. And so then I can test again the input of the system, obtaining something that is different. And so I can understand the behavior of the system with some specific faults. We use this platform for evaluating our classifiers. We published the platform and the data in a conference, and we found that and we used the platform for emulating a radiation test experiment and also for identifying the failure rates for specific fault models. So that's it, and if you have any question, I'm available for answer.